So let us start with the next chapter, that is forced vibration. So various active and reactive forces are shown in the figure. So here F0 sine omega t is the disturbing force or active force, and all these are the restoring force. So we are having a mass which is supported by spring and dashpot or damper, and this is the direction of motion, initial direction of motion to this particular spring mass system or spring dashpot mass system. So F0 sine omega t is the external disturbing periodic force. F0 is the magnitude of the force and sine omega t represents the frequency or direction part of the forces. Kx is the spring force, which is the restoring force. Cx dot is the damping force. Mx double dot is the inertia force, which is opposite to the direction of motion. So let us draw the free body diagram. So this is the direction of motion. F0 sine omega t is acting, suppose, in the downward direction. To the direction of motion, opposite force is the inertia force, mass into acceleration, spring force kx, damping force cx dot, and F0 sine omega t we have assumed in the downward direction. After some period of time, it may act in the upward direction. So equation of motion is, so all these three forces, they are acting in the upward direction, they have considered as positive. So inertia force plus damping force plus spring force minus F0 sine omega t. This is the downward acting external periodic force, and that is equal to 0. Transfer this negative force on this side. So it is F0 sine omega t. Now we have to derive the expression for equation of motion in the simplified form. Now let us start with the derivation of forced vibration. So we have already seen that in case of forced damped vibration system, the equation of motion is given by mx double dot plus cx dot plus kx minus f0 sine omega t is equal to 0. So the various forces, as we have already seen, are the inertia force, damping force, spring force, and external force, which is magnitude and the value of frequency given by sine omega t. So f0 is the amplitude or magnitude, and sine omega t part is the frequency part of the external force. Now here we'll assume x is equal to a sine omega t plus b cos omega t. The sinusoidal variation is there. Now differentiate this equation. So a is a constant, so we'll have derivative of sine omega t plus b is a constant, we'll have derivative of cos omega t. Now derivative of sine omega t is cos omega t, and again by chain rule we have to take into consideration the derivative of omega t. So derivative of sine is cos, instead of t omega t is there, so we have to differentiate again this term omega t. So this is the chain rule. Derivative of cos is minus sine omega t, and again derivative of the term, that is omega t. Omega is a constant term, we can take it outside, so we'll have derivative of t with respect to t, and that is nothing but equal to 1. So omega we have taken outside, so it is derivative of t. Here also plus minus, that multiplication is minus b sine omega t. Omega you can take it outside, so it is derivative of t. Now derivative of t with respect to t is 1. So it is a omega cos omega t minus b sine omega t into omega, or b omega sine omega t. Again differentiate this term. So now we'll do it directly. Minus a omega, derivative of cos is minus sine omega t into omega. So that omega and this previous omega, that is omega square. Similarly over here also minus b omega square cos omega t. Now substitute these values of x, x dot and x double dot in equation 1. So equation 1 is mx double dot plus cx dot plus kx is equal to f0 sine omega t. So x double dot, this is the value of x double dot. X dot is a omega cos omega t minus b omega sine omega t plus kx. X is a sine omega t plus b cos omega t is equal to f0 sine omega t. So we have substituted the values of x double dot, x dot and x. Now multiply by m inside the bracket. So it is minus ma omega square sine omega t m into minus b omega square cos omega t, that is this particular term, c a omega cos omega t minus c b omega sine omega t plus ka sine omega t plus kb cos omega t is equal to f0 sine omega t, and there is no cos term, so we can say that 0 multiplied by cos omega t. Now we'll collect the terms which are having sine omega term, omega t terms in them. So you can see this is minus ma omega square, here it is minus cb sine omega t and plus ka sine omega t. From these three terms, we can take sine omega t common. Now the remaining terms are there. So the remaining terms are minus mb omega square plus ca omega plus kb. And from these three terms, we can take cos omega t common. And that is equal to f0 sine omega t plus 0 multiplied by cos omega t. Now we can equate the coefficient of sine omega t and cos omega t from both the sides. So equating the coefficients, we can say that on the left hand side, coefficient of sine omega t is this bracketed term. On the right hand side, the coefficient is f0. So we can say that minus ma omega square minus cb omega plus ka has to be equal to f0. Whereas coefficient of cos omega t is minus mb omega square plus ca omega plus kb is equal to 0. Coefficient of cos term is 0 on the right hand side. So these are the two equations which we have obtained. Now from first term and the last term we can take a common. So it is minus m omega square plus k multiplied by a minus cb omega is equal to f0. Let us call this as equation 2. Similarly, from this term and this term, we can take b common. So it is minus m omega square plus k multiplied by b, and this ca omega term as it is. So let us call this as equation 3. Just rearrange the term. So second equation, k we have written first, minus m omega square a minus t omega b is equal to f0. Here also k we have written first and then minus m omega square multiplied by b plus c omega a is equal to 0. Now we have to solve these equations simultaneously. So you can see c omega is the coefficient of a over here. So we can multiply by c omega to this particular term. Then k minus m omega square is the coefficient of b. So we can multiply this equation by c omega and this another equation by k minus m omega square. So this is k minus m omega square multiplied by c omega multiplied by a minus c square omega square, c omega into c omega, that is c square omega square is equal to f0 multiplied by c omega. Here also k minus m omega square and square of that, because this is multiplied by the same term, multiplied by b plus c omega multiplied by k minus m omega square multiplied by a. So, and that is equal to 0 multiplied by this term, that is same term. So we can say that we can cancel out these terms. So if you subtract this equation, then this plus will become minus, this plus will also become minus, and here also this plus 0 will become minus 0. That is this term minus 0. Now here this plus k minus m omega square c omega a, and here also k minus omega square c omega, but negative term, so that will get cancelled out. So we are having minus c square omega square b minus k minus m omega square multiplied by b is equal to f0 c omega minus 0, that is nothing but f0 c omega. Now take b common from this with negative sign. So if you take minus sign also common, this minus minus term will become plus. So it is c square omega square plus this term is equal to f0 c omega. So ultimately one of the constant that we can easily achieve by taking this minus sign also on this side. So it is minus f0 c omega divided by c omega bracket square plus k minus m omega square bracket square. So c square omega square can be written as c omega and square of that. Now we have to calculate the value of a. So from equation 3 we can say that you can substitute this value in any of the equation, second or third equation. So we have considered the equation 3. So it is minus m omega square plus k multiplied by b plus c omega a is equal to 0. K we have written first minus m omega square. Now value of b which we have just now obtained is this particular value, which we can substitute at the place of b. So this value we have substituted plus c omega a is equal to 0. So we can say that c omega a will be equal to, now this minus term it will go on the other side, it will become positive. So f0 c omega divided by the denominator is same, and this k minus m omega square term is also same. So c omega we can cancel out from both the terms, both the sides, that is left hand side, and so c omega will get cancelled from LHS as well as from the RHS. So a will be equal to this f0 k minus m omega square, and in this denominator as it is. So this is our fifth equation. So now we are having a and b, both these equations with us. So let us assume that k minus m omega square is equal to z cos phi and c omega is equal to z sin phi. Now if you square and add them, then k minus m omega square plus c omega and square of that is equal to z square cos square phi plus z square sin square phi. If you take z square common on the right hand side, then it is cos square plus sin square, that is nothing but 1. So we can say that value of z will be equal to, we have to take square root on both the sides. So square root of z square is z, and here square root will be k minus m omega square of that plus c omega bracket square. So this is the value of z. If you take the ratio, then z sin phi divided by z cos phi will be equal to z sin phi value is c omega, z cos phi value is k minus m omega square. Z will get cancelled out. Sin upon cos is tan. So phi will be equal to tan inverse of c omega divided by k minus m omega square. Now consider the expression for z again. So it is k minus square root of k minus m omega square plus c omega bracket square multiplied by k square and divided by k square. So this is now very important term. So this k square which is there in multiplication, we will keep it as it is, but division of this k square, that term we will take inside. So it is k minus m omega square divided by k square plus c omega square divided by k square. So this k square which is there in the denominator or division, that we have divided over here to both these terms. So this is k minus m omega square divided by k bracket square. c omega divided by k bracket square. K divided by k, that is 1. This square root of k square, this we have taken outside, so it will be only k. And this is c omega by k bracket square. So this k upon k, that is 1, minus m omega square upon k, separating the terms, bracket square, plus c omega by k and square of that. Square root of k square we have taken outside and it is k. Let us call this as our equation 8. Now already we have seen this omega n is equal to square root of k by m. If you square both the sides, then omega n square will be equal to k by m. Take a reciprocal of this, so 1 upon omega n square is equal to m upon k. Similarly, zeta is equal to c upon 2 square root of km. So in the under root, if you multiply by k and divide by k, then what we'll get, that also we'll see. So here we can say that this is nothing but m upon k multiplied by k, that is k square into m upon k. Now m upon k, just now we have seen that it is 1 upon omega n square. So our previous equation, that is the ninth equation, is, so take square root of k square. If you take it outside, square root of k square is k, and square root of m upon k, just now we have seen that it is 1 upon omega n square, and if you take square root of that, it is 1 upon omega n. So we have to find out this value, c upon 2k, or rather c upon k. So c upon k will be equal to 2 zeta cross multiply by this 2 to this zeta divided by omega n. So we are now having the value of c upon k also, and that is our equation 10, and that value is 2 zeta upon omega n. So value of c upon k and value of m upon k, which we are now having with us, we can substitute those values in equation 8, which is nothing but the equation of z. So k and square root of this term. This is our equation 8, and in this equation we have to substitute the value of c upon k and m upon k. So let us substitute these values now. So this is 1 minus m upon k. So value of m upon k is 1 upon omega n square. So it is 1 upon omega n square. Omega square is already there, and square of that term. C upon k value is 2 zeta upon omega n. So it is 2 zeta. This omega is already there, divided by omega n. So once again see, m by k value is 1 upon omega n square. So 1 upon omega n square is there, and omega square is already there. So omega square upon omega n square. C upon k, it is 2 zeta divided by omega n. So this is the value of c by k, but omega is already there, so that also we have written. So now here we are getting the term omega upon omega n, that is the frequency divided by natural frequency, and that is nothing but the ratio of the frequency. So we can call this omega upon omega n as r. So this is 1 minus r square and square of that, plus again over here also omega upon omega n is r. So it is 2 zeta r and bracket square. So now we have expressed the value of z in terms of r and zeta. K is the stiffness. Similar to that, we have to express value of phase angle phi also in terms of zeta and r. So here also we'll do some modification. So divide numerator and denominator by k. So that we'll get c by k term and m by k terms. And then we can easily substitute those values which we have already derived. Value of c upon k is nothing but 2 zeta upon omega n, and this omega is already there. So k upon k, that is 1 minus m by k omega square. So c upon k, just now we have seen that it is 2 zeta upon omega n, and this omega is already there. So it is 2 zeta omega upon omega n. M by k is 1 upon omega n square, and then again omega by omega n is r, that is frequency ratio. So this is 1 minus r square. So this is the value of phi, which is also expressed in terms of r and zeta. We'll continue with the derivation in our next lecture.